say we have a multicast address of 224.1.1.1. I'm going to send it out to this address. And this is saying that, look, I am the source right here, and I'm communicating to this address. Now, really what this means is I will be communicating to anyone who is listening on this particular address. And that's interesting because multicast is the way of having PCs listen on an address. So if this PC, if all these PCs are circled and they're listening on 224.1.1.1, that means when 192.168.1.1 sends traffic to the 224, the only ones who are going to get that traffic are the ones who are listening. Now, a switch will still send it out of all ports. It treats a multicast as it does a broadcast. A switch will treat a multicast just like it would a broadcast. So these switches will get it, but they'll drop the information because they're not listening. So that's really nice to be able to have traffic coming from one source and going to many. And that's the concept of multicast. So you'll be using a special type of address to do this type of communication, but it's one-to-many. So unicast is one-to-one, broadcast is one-to-all, and multicast is one-to-many. Now, anycast is a little weird because imagine having this cloud here. And you got your router 1. And you got your PC sitting over here somewhere. And you go out and you want to find a web server. And let's call it Yahoo. And we got these 3 Yahoo servers scattered across the world. The interesting thing about this is I'm going to give each one of these servers an IP address. Now, you would think that I would give them different IP addresses, but this is the one time that I can actually have the same IP address. And with any cast, let's say it's 200.1.1.1, this one's going to be 200.1.1.1, and so is this one. The concept with Anycast is this message goes out, and then whoever gets this information first will respond back to that PC. Now, based on what I understand about Unicast, is these bad boys will have communication with each other somehow, and, it'll stop them from, once they realize one is responding to it, this one here, we'll say server 1. Server 1 might get the information and say, okay, I'm going to respond to this, guys, and let server 2 and 3 know that, guys, I got it. Don't worry about it. But you're not going to be dealing with Unicast. You're going to be dealing with, you're not going to be dealing with any cast. You're going to be dealing with Unicast, broadcast messages. Multicast, you will deal with in some aspect, but you won't be learning multicast in that fashion as far as building a multicast network. And these are our communication types. So when I say unicast in the future, you should know what unicast is. If you don't know, you need to go back and review to find out what it is. Unicast, this term right here, uni means one. Multi, this means going to many. And broad means you're hitting everyone. Now, let's talk about basic communication. Remember in the very beginning when I told you that a PC needs 2 things to communicate. It needs an IP address and a MAC address, which means without these 2 things, a PC using TCP/IP cannot communicate. It cannot happen. Now, since the main thing we need always with communication is IP address and MAC address, because of that, every PC builds the information that's going down. Now, you saw as I was building this information, when PC 1 has to send this information out to PC 2, he's going to have our data. Now, we're talking about basic communication, so we're not going to have layer 4 information in there. But we are going to have the source IP and the destination IP. Now, the source IP obviously is going to be me, and the destination IP is going to be the IP address that we're trying to communicate with. So since I'm getting the destination IP address from PC1, because that's the PC I'm communicating with, so if I'm sending a ping, and I say ping 192.168.1.2, well, obviously, me typing this in is going to force the PC or tell the PC, this is your destination IP that we're trying to communicate with. So that will go here. .1.1, right? Or 1.2. That's where it would go. And the source would be me. Now, the source MAC and the destination MAC, that's something a little trickier. Because the source MAC, I know what my source MAC is because it's my network card. All I got to do is look at my network card and get the source MAC. No big deal. But the destination MAC is a little different. How do I fill in this field? I must have a way of being able to fill in this field. And the only way to do this is to have a list of MAC addresses on my local PC that corresponds to the IP addresses. Now, this is important to know because I need some type of table to say, look, the MAC address, if this was the MAC address of BB, :BB, I would say, look, the MAC address of BB equals 192.168.1.2. If I had this type of information on this PC, a PC1, then when I go to build my source MAC, which is easy to do, and my destination MAC, which is not so easy to do, all I would have to do is look in this table and say, oh, I have an entry here for 192.168.1.2, and that MAC is BB. And this is how my destination MAC is built if I had this table. Now, wouldn't that be wonderful if a table like that existed? And it does. And it is called ARP. Address Resolution Protocol. And what ARP does is it builds a table for each local PC. Every local PC has every PC has an ARP table, and it builds its table by matching IP addresses to MAC addresses. Now, when this happens, it has to get the information from somewhere, shape, or form. This table isn't magical. So let's find out what happens. PC1 tries to communicate. Now he starts going down and he starts building his information. First, takes his data. Then he takes his layer 3. Source IP, destination IP. Then he goes and he builds the source MAC. And then he tries to do the destination MAC, and he's like, okay, so what do? I need to look in my what? My ARP table. Guess what? I don't have an entry for my ARP table. Now, that's kind of interesting because what am I looking for? I'm really looking for the MAC address, my destination MAC. I'm looking for the MAC address of my what? Destination IP address. If the destination IP address is 192.168.1.2, what's the MAC address? I'm going to look in my ARP table. And I'm looking for the 192.168.1.2 address in my ARP table so I can find the MAC address of that IP address. But guess what? It's not there. If it's not there, what do I need to do now? Well, I'm going to have to send out what is called an ARP request. And in that ARP request, I'm going to have the source IP of 192.168.1.1. I'm going to have the destination IP of 255.255.255.255. Wait a minute, what did we just learn about that? That's a broadcast address. I'm going to be sending out a broadcast. Well, what else do I need? What do you always need for communication, no matter what you're doing? IP address and MAC address. So even with this ARP request, I have to fill out these headers. Wow. Yes, everything that goes out, it needs to go through that stack. So I'm going to have a source MAC, and we'll say that source MAC is AA:AA, which will be this PC here. Easy enough, look at my own network card. And I'm going to have a destination MAC because I don't know what it is of all Fs. Now this packet or this frame goes out and hits this switch. What does a switch do with a broadcast? It sends it out every port except the port that it came in on. And you're going to hear me say that a lot more times. A switch will send the broadcast, all broadcast messages, out every port except the one it came in on. So that broadcast hits this, goes out all these ports, including this one. That traffic gets over to here. He's going to look at the destination MAC, the layer 2 information, and says, oh, it's a broadcast. Well, I'm going to open it. It's a broadcast. Well, if that's a broadcast address, I'm going to open it, man, because broadcast goes to everyone. So I'm going to open up the information. I'm going to say, oh, it's an ARP request. Okay, well, let me respond to that ARP request. This might be incorrect. You might want to go back into your Wireshark and pay attention to this aspect of it, because this might be broadcast as far as layer 2 because we don't know the MAC address. But since we have the destination IP address originally when we did our ping, this most likely will be the IP address of 192.168.1.2. Nonetheless, I want you to think about the logic here. Whether I'm 100% accurate that this is a broadcast or not, it's either going to be a broadcast or a unicast. Whether it's a broadcast or a unicast, guess what? PC2 is still going to get it. Well, let me reply back to that. So he's going to have his data, and he's going to respond by filling out the layer 3 information, source IP and destination IP. Let's do that. Source IP, it's going to be 192.168.1.2. That's my address. Destination IP, 192.168.1.1. Where do you get this information from? How does he know that the destination needs to go to 1.1? Because when PC1 originally sent out the information, the 1.1 address was in his source field. So PC2 is smart enough to look in the source field when that data comes in and says, oh, this is a ARP request. Well, I'm going to take that source information, and since it was sourced from 1.1, I'm going to send it back to 1.1 with the information that 1.1 was requesting. All from the layer 3 header. Layer 2 looked at the layer 3 header, saw that it was sourced from 1.1, so he's going to destine that information back to 1.1. Now here, this is when it gets interesting, because now he's going to source, his source MAC is going to be his address, which is BB, and the destination MAC, which he already had in the layer 2 information, AA. So now PC2 has all his fields filled in. He sends that information back over to PC1. And when PC1 gets it, he's going to see all this information. And when he sees all this information, He's going to say, oh, it was sourced from BBBB. So the source IP address, which I was trying to communicate, the destination IP address of 1.2, this information is now being sourced from 1.2, which is the original PC I was trying to communicate with anyway, and the source MAC address of 1.2 is BBBB, which means that is his MAC address. So now I get to fill in my ARP table, BB:BB. Now that is done. Now I have the ability to communicate with PC2 directly. And from here on out, I'm going to be filling out my destination IP 192.168.1.2. And now my MAC address is going to be BB:BB. And where did I get this information? Bam. I got it from ARP. Man, that's just crazy. Are you telling me that everyone has an ARP table? Yeah. It's a poor guy in my class who, the poor guy was for some odd strange reason believed that, PCs don't have ARP tables. And I'm like, yeah, they do. All PCs have ARP tables. So let me show you. And I did this command. I'm like, there's your ARP table. And the poor guy never came back to my class again. I don't know why. Guys, it's very common to make mistakes. It's very common. I can guarantee you I just made a mistake right now on this video about that being a broadcast layer 3 address. I can almost guarantee that it's a unicast. Guys, do I care? No. Is it embarrassing? Of course it's embarrassing when you can't remember anything. That's part of us being human. Yeah, it's embarrassing. We want to know it all and be right all the time. But guess what? We're not. Because we are human, we do get embarrassed, and because we are human, we do forget. Learn to get past that just by screwing up 1,000 times. When you screw up 1,000 times, you get so used to it, your 1,001 time doesn't really matter. I screw up all the time. Just don't let it affect you to the point that you don't want to learn anymore. That's the ultimate key.